Hey guys, today we are going to review properties of triangles. So we're going to go over classifying triangles, then isosceles and equilateral triangles, and then proving triangles congruent. And we'll split this into 3 short videos. First, classifying triangles. So we want to draw a triangle to match this description, one that is obtuse and isosceles. So it needs one obtuse angle and 2 sides that are the same length. So here is an example of a triangle that is obtuse and isosceles. So this angle is our obtuse angle. These 2 are the same, so it is isosceles. Isosceles and right, so 2 sides of the same length and a right angle. Okay, so the legs of this right triangle are congruent. It's got that right angle right there. That makes it isosceles and right. And then one that is equilateral. So that means all 3 sides are the same length. Okay, now classify these. Sorry about that. So we are going to classify each triangle by its sides and angles. So this is one obtuse angle. So I know it's an obtuse triangle. And I have no indication that any sides are the same, and that makes it scalene. So this is scalene and obtuse. Here's a right angle, so this is a right triangle. And once again, I have no indication of any sides being the same, so it is scalene. So this is a scalene right triangle. And here I have 2 sides the same, so it is isosceles. I have 2 75-degree angles, and this one appears to be acute, and here's how we can tell. I can do 180 minus 75 minus 75 and figure out that last angle measure. Now this 75 and 75 is 150. 180 minus 150 is 30. So this is a 30-degree angle. So all of the angles are acute. It is isosceles and acute. Okay, now we need to graph some triangles and then classify by their sides and then say if they're right triangles or not right triangles. So I have 3, 1. Now be careful, we've got a scale of 2 here. So this is 3 and this is 1. So there's 3, 1. So that's A. Then I have 3, 4, that's B, and I have 7, 1, so that's 2, 4, 6, 7, and 1, and that is C. Okay, now I have a horizontal line and a vertical line. That makes a right angle. So I can definitely say it is right. Okay, now I can count the horizontal and vertical segments. So I've got 1, 2, 3, 4, and then 1, 2, 3. Okay, and on a right triangle, the hypotenuse is always the longest side, so it's bigger than 3 and it's bigger than 4. So no sides are the same, so it is scalene and it is right. Okay, next I have 1, 1. And again, we have a scale of 2, so 1, 1 is right here, so that's X. Y is 4, 0. And then Z is 8, 5. Okay, so there's triangle XYZ. Okay, so right here, if I have a right angle, this would be it. So let's check the slopes here. So this right here, this slope of XY, it goes down and right, so it is negative, and it goes down 1, right 3, negative 1/3. And the slope of YZ, if that's the opposite reciprocal, so that would be positive 3, then this is a right angle. So it goes up 2, 4, 5, and right 2, 4. Those are not opposite reciprocals. That's not a right angle. So there's no right angle in this, so it is not right. And clearly those sides are not the same, so this is scalene, and it is not right. And our last triangle, QRS, and now we're on a scale of 1. So 4, 2 is right here, so that's Q, 4, -3, R, and 1, 2, S. Okay, now this is clearly a right triangle because I have a horizontal and a vertical segment. So it is a right. 1, 2, 3. This side is 3. 1, 2, 3, 4, 5. And again, a hypotenuse of a right triangle is the longest side, so it's not the same as the 3 or 5. It's longer than both of those. So no sides are the same. It is scalene, and it is right. Now, if I need to see if any slanted sides are the same, I can use the distance formula. So let's practice that here. So if I want to know segment XY, I would do x minus x, so that's 1 minus 4 squared, plus y minus y, 1 minus 0 squared, and then the square root of that. So I've got -3 squared is 9. And then 1 minus 0 is 1, squared is 1. So I have the square root of 10. Okay, now we'll do the same for YZ. So for YZ, I have 4 minus 8 squared plus 0 minus 5 squared under a square root, so that's -4 squared, which is 16. Okay, and then I have 0 minus 5, which is -5. Squared is 25. Okay, 16 plus 25, that's the square root of 41. Those two are definitely not the same. And then I could do the same for XZ, and I'll have all three side lengths. So for XZ, I've got 1 minus 8 squared, and then 1 minus 5 squared. So that's -7 squared, that's 49. And then -4 squared is 16. Okay, so I've got 49 plus 16, that's 65. Square root of 65. So no three sides are the same. That makes it scalene. If two of these are the same, it's isosceles. If all three are the same, it's equilateral.